Hello folks, welcome to my YouTube channel CSIT Zone. Today we are going to discuss about memory hierarchy. To understand this memory hierarchy, we are having a memory hierarchy diagram. In this diagram, the smallest memory is on the top and the largest memory is on the down. So in the first position we are having register. Register is one of the smallest set of data holding places that are part of the computer processor. And on the second position we are having the cache memory. Cache memory is stored frequently used instruction and the data for the quicker processing by the CPU of computer. The cache is an extension of computer's main memory. Now at the third position we are having main memory, or we can say the primary memory. It is a computer memory that a processor or computer access first or directly. Example of this main memory is your RAM, random access memory, your ROM, read-only memory. Now at the last position, the greatest memory in the computer is secondary memory. It is a computer's memory that is non-volatile, persistent, and not immediately accessible by a computer or processor. Example of this memory is your hard disks, CD, DVD, etc. Now let's move on to the another topic, which is dual mode operation of operating system. In the hardware level, the instructions are executed in two different modes, like user mode and the kernel mode. User mode can also be known as non-privileged mode, and the kernel mode can be known as privileged mode, system mode, or monitor mode. The dual mode operation is used in order to provide the protection and security to the user program and also to the operating system from errant use. It is the purely decision of operating system in which particular mode the instruction has to be executed. Generally, the privileged instructions are executed in the kernel modes and the non-privileged instructions are executed in the user mode. Now, what are these privileged instructions? Privileged instruction can be your input-output operation, context switching, disabling interrupts, set the time of the clock, cleaning the memory map, changing the memory map. The non-privileged instructions can be your reading the time of the clock, reading the status of the processor. Now, what is this mode bit? Mode bit is used to identify in which particular mode the current instruction is executing. The kernel mode is denoted by the 0 bit and the user mode is denoted by the 1 bit. In the boot time, system always start in the kernel mode. The operating system always runs in the kernel mode. Now, the most important thing is the mode switching takes very less time in compared to the process switching. Now, let's move on to the another topic, which is layered approach of operating system. The design and implement of operating system will be done in the multiple layers. The various layers are process management, memory management, file management, device management, and the last, protection and security. The main advantage of layered approach is abstraction, debugging, and modularity. Modularity means if any specific layer is updated, then it will have not any impact onto the another layer. Now let's move on to the another topic, which is fork. Fork is a system call used to create the child processor. Before move to the further discussion, let's understand the program. In this main function, we initialize PID as integer. Then fork function will assign to this PID. If PID is lesser than 0, means negative value, child process will not be created. If PID is equals to 0, then the child process will be created, and if PID will be greater than 0, then the parent process will be created. Now, when the child process is created, new memory location will be allocated to the child process. Parent and child process will have the same virtual address but the different physical address. Now let's understand the example. In the example 1, we are having one fork system call. So one child process will be created. In the example 2, we are having two fork system call. For the first fork system call, below that one more fork system call is there. For the first fork system call, two child processes will be created. And for the second fork system call, it is the last one, so only one child process will be created. The overall mean is that if we have n fork system call in the program, then we have 2n-1 child processes will be created. Here the value of n is equals to 2. Let's put the value of n into the formula. We get 2 raised to the power 2 minus 1. As the result, 4 minus 1, we got 3. So we have 3 child processes created. So that's all for this video. Let's meet in the another video of the series. If you like this video, please do like, subscribe and share so other also get benefit of this.